Hello students, this is Brock Skaggs. I'm going to make another video demonstration of using SolidWorks to perform some basic part modeling. And so you can see the isometric view of what we're going to try to model today. It's a model based off of a timing belt pulley. A lot of it is axisymmetric, and so you've got this one axis there that's going to run through the origin, and there's a lot of symmetry about that axis. So one of the things that we'll be illustrating are some of the features that SolidWorks has to help with those type of geometries. Namely, we can use things like the Revolve boss and base command, circular pattern, and so forth there. Those two probably being the two big ones there. You can see a circular pattern of the cut slots in here to kind of create that spoke pattern. And they also have these small ridges that wrap around there. You can see the unit system is IPS. Material is alloy steel. And so going into sheet 2 here, we've got the usual items there in terms of the front, top, and right views. And then I also have a detail A showing the blown up view there so I can see the dimensions associated with those little ridges, or little teeth if you will. So there are 50 teeth total. There's a global note there to discuss rounds and fillets that aren't marked that have a radius of 1/4 inch, and the rib cuts are through all. And so, as usually, I would encourage you to go ahead and pause the video at this point and see if you can model this on your own. And then you can obviously watch the remainder of the video there to see how I go about modeling it. And then toward the end, we'll talk about mass properties and make sure we're at the right spot. And so it looks like I don't have SolidWorks going, and so I'll go ahead and take a moment to let SolidWorks boot up here. And so here's SolidWorks 2015. We'll go new. We're doing a part. We'll just set the default template there. IPS units is good. We said this was alloy steel. And so let's go ahead and apply that as usual. So right from the steel folder, we can come down to alloy steel and apply that to the model. So a little bit of thought process. How are we going to map this thing out? And so first, I'm going to start off using the Revolve tool in order to create the majority of the geometry. I'll create all the solid geometry except for the teeth that are wrapping around there, that pattern of 50 instances there. And then we can just start removing material as needed there. And so we can put that 3/8/16 hole in. We can go ahead and create the cuts to create the spokes. And then we can also create the add-on material for the teeth itself there. And so it's a very quick run through of how I'll go about modeling this part. And so we also need to pay attention to origin placement. You can see it's right here. It's actually on the plane that's associated with this face here, and it's right concentric with the hole. And this is the isometric view. And so what I'm going to do is create a revolve feature first. And so I need to be careful on which plane that I make that sketch on. And so in order to make it fit into the isometric view here, I'm actually going to want to revolve it from a sketch that's on the front plane here. And so as I get into the sketch on the front plane, it should be fairly obvious. And so one thing I usually like to do on Revolve features is create a center line first. And so right under the line there's center line. And I'm just going to draw it at the origin and work my way off to the right a little bit there, making sure it is horizontal. The center line is going to be the default thing that SolidWorks looks for when it goes to make a revolve boss or base or revolve cut there. And so I've already got it in here, so that'll be well defined. And so now I'll just go about creating the geometry. And so, or excuse me, creating the sketch for the geometry. And what I'm looking at is basically the top part of the front view here. And so I've got a horizontal line, a vertical line, a small horizontal, small vertical, longer horizontal, longer vertical, another horizontal and a vertical there. So I'm just basically looking at the profile associated with 1/2 of the front view. And so we'll go ahead and get into SolidWorks here, get the line tool going, and see if we can get that going. And so here, just making lines, notice all of them are either strictly vertical or horizontal. Let it pick up that reference to the origin, and there we go. And so that should look very similar to this kind of stair-step approach of the top half of this component. And so now let's go ahead and start applying some dimensions. So 2 inches is this dimension here. Actually, I've messed up a little bit here because this is not supposed to be at the origin, right? There's a hole there, so I can actually do that all in one step. Here, I'll go ahead and move this guy up a little bit, and I'll go ahead and redo my center line so it's horizontal here. I could have done it the other way. I just would have had another feature to create the hole. And so we said this right here is 2 inches. Now with center lines, you can measure or apply dimensions in 2 different ways. One is right here, where I'm measuring just the radius of this. But if I take my mouse and just drag it past the center line, you can see it jumps the extension line to the other side of the part there. And so this is associated with the diameter dimension there of 2. The hole we see from the right view has a diameter of 1, so that'll be this guy. And again, I'm going to be dragging past to get to the diameter. Here we're going to have to worry about this. And so we know that's got to be exactly vertical with the origin. So I can just select one point, hold control down, select the other point, and then I have my relation options here on the left-hand side. So I want to make sure that those go to vertical. Looks like 1.25 is that first horizontal length. And so I'll go ahead and apply that. The next diameter actually is going to be this 5, and so it's a little hard to tell here, but the 5 is associated with this ridge right here before we add the teeth. So you have to really zoom in on that PDF to see it. So there's my 5. The outer diameter is 5.5. So there I already had the center line selected, so I'd automatically jump to that. Looks like the thickness is here for that very largest diameter circle, a thickness of 1/4. So that would be this horizontal line here. And this 2 1/4 dimension goes from this very front face to the front face of where that large diameter portion is going to be. So basically between this vertical line and this vertical line needs to be, was it 2 1/4? Yes. So at this point we've got all of our dimensions in, we've got all the relations as usual, and we're at a nice fully defined sketch. And so I'll go ahead and exit the sketch, and then I'll go straight into features. Notice the sketch is still selected, and so I'll go right into Revolve Boss and Base. And so I'll go ahead and put this in the isometric view. And remember we talked about it had to be on the front view. That's because when I go to Revolve Boss and Base, it's basically going to rotate this thing about the x-axis there in order to create the geometry. And so that center line, it's already picked up as the axis of revolution. We're doing a blind extrusion through just the usual 360 degrees there. And so I'll accept that. And there is a rough part of our little timing belt pulley there. Here I can make a very quick reference back to the cover sheet here. This is the isometric view, so the orientation looks appropriate. And then also I'll check the origin placement right there in that little blue dot. And so that looks appropriate as well. So we're off to a good start. So next, what do? Let's work on the cuts associated with the spoke pattern here. And so in the right view, it does look like they're all equally spaced. You can see the kind of spoke geometry is 1/4 inch thick. And so we'll just start with that. And so what's the sketch plane going to be? Well, we'll pick this face right here. That'll be a good sketch plane for us. And so I'll just select the face, and from the little quick access toolbox here, I'll go to the sketch icon. And go normal to. So it looks like the cuts go right up to the bigger boss here, associated with the hub. And so here I'm just going to use convert entities. I'll select that edge, go convert entities, and make that sketch circle. And then I've got a larger circle here. It is going to be concentric, so it'll start at the center point and it's somewhere out here. The diameter of that circle, it's not best way to dimension it probably, but I've got this 1/4 inch thickness here. And if you can see, you basically have a circle associated with this diameter here, and the circle associated with the bottom side of these teeth. That 1/4 inch dimension is what needs to go here. And so I can just select those two entities, one being the sketch circle, one being the circular edge, and I can tell it to be a 1/4 inch dimension offset there. So that looks appropriate. And now for some construction geometry. And so what I'm going to do is draw a couple lines here. You can see one's vertical, the other one's at some angle. Both of them meet at the origin. And you can see there's 1, 2, 3, 4, 5, 6 of these, equally spaced. And so this is going to follow 360 divided by 6, or 60 degrees there. And I'm not going to use these to actually define the cutting boundaries of this cut extrude. So what I'm going to go ahead and do is turn them into construction geometry. So notice all I'm doing is left clicking on them. You can either select the construction geometry from the little box that pops up, or on the left hand side under options you have the ability to tell it to be construction geometry as well. And so these edges here of the cut, the line portions of them, are offset 1/4 inch from each other to make the spokes. And so what I'll do is I'll come in here, I'll draw a vertical line here, and I'll just draw a line at some random angle there. Oops, let's go back to normal 2. And so the first thing I'm going to do is tell this one to be parallel. You can see the geometric relation there from the box when I have them both selected to that inclined line at 60 degrees. Next I need to extend these, and so I could just drag the endpoints and make them touch the circles just like that. Or what I can also do is go right under trim entities as extend entities, and so here just selecting near the ends of the lines, have them extend until they hit the next entity in its path. Now for the dimension for the 1/4 inch spoke width, and so there it is. Again, you've got the ability to watch the extension lines, whether it's going to be kind of a radius style dimension or the overall width in this case. So it's 0.25 here. Similarly here, again, this would be an instance where I could just hard code a value in here, or I can make it a little bit smarter and say, hey, just drive off of this other dimension. That way, if I was to change the spoke width at any point, I would just be changing one dimension and the other one automatically update for me. We don't really need all these circular arcs here. We don't need to go all the way around, so let's go ahead and trim entities and just power trim some of these off. And so I'll just power trim here, power trim there, and also get in between here. There we go. One thing of note is that you do see a little blip of blue here in the sketch, but it's still saying fully defined. The reason this works out is because the length of these construction lines in this case does not matter. The orientation does matter, which I've defined. This one's horizontal and this one's 60 degrees rotated clockwise from the horizontal. Also notice the position there because they're both tied to the origin, but the fact that this line is really short or really long doesn't really matter there. If it does bug you, you can just pick some natural place, such as that edge and this edge, in order to define the length of those lines, and it'll get everything black to you. But notice even before that, for those construction lines, the little blue endpoints was not interrupting our fully defined status of the sketch. So we're fairly close. One thing that we're lacking is these rounds. There are 1/4 inch rounds, remember from our global note here. And so I'll go ahead and just place those inside of the sketch using the sketch fillet. So sketch fillet there, 0.25 is the round radius. And I'll just select the vertices here in order to create these rounds. Note I could have also done that outside of the sketch as a feature fillet after I created the cut extrude. And so this looks good. At this point, one thing I could do is I could circular pattern inside the sketch. SolidWorks does have the ability to do that, but it's my personal preference to usually create the feature and pattern at the feature level. And so that's what I'll do for this one. I'll go ahead and use this as my seed feature. And so what I'll do is I'll exit the sketch. I'll go to the extrude cut because I'm going to remove the material. These things go through all, so might as well use the through all constraint. You can see the nice preview. And accepting it there allows me to arrive at my seed feature. Now I just need to pattern this. I need to pattern it a total of 5 times to create a total of 6 instances. And so here I'll go straight into not linear pattern, but right underneath it is circular pattern. So circular pattern is first wanting the feature to pattern. And so again, I'll select it from the drop down here. You can also select it from the graphics area if you like. For the pattern axis, I'll just select the inner cylindrical face of the hole, and it generates the preview. See, the last one I did in preparation for this video was 50. Here, that obviously is not what I'm looking for, and so I'll put in just 6. And you can see the Nice patterning effect there. And so the 6 does count the seed feature, you can see. Other pieces of software may do that a little bit different, but SolidWorks does count the seed feature in this quantity. So I'll accept that. And as you can see, we have the nice spoke geometry there. So let's next go ahead and create the teeth on the outside of this thing. And so the teeth, a lot of the dimensions are right here in the detail view. So I'll just pan up there. You can see they're 1/8 inch wide, 50 thousandths tall, and this one here is centered right on the vertical midplane here. So to create that, I'm just going to select this face right here and go to Sketch. Again, I like to sketch normal to the plane, so I just go right here. I can go normal to, or you can also see the shortcut key, Control+8, that you'll also see me use at times. Next, I might as well use Convert Entities to basically map that edge to a sketch circle. That's one less thing I have to draw and define myself. And then what I'll do is I'll come in here and draw the 3 sides of kind of the rectangular edges of this tooth. Again, when you use convert entities, you have to be careful because you might not need everything it converts. Like here, I don't need the entire circle that's in orange. I just need the little bit of the arc that's underneath my lines here. And so I'll use trim entities to trim off the majority of it and just keep the part that's in between those line segments. And we said it was 1/8 inch for the width, 50 thousandths here for the height. And here I'm going to say that these 2 line segments have to be equal in order to center it there. And so now I've arrived at this nice fully defined sketch that'll help me build this tooth profile. And so if you kind of rotate the model, you can see it's right on that front face. So here I'm not even going to exit the sketch. I'm just going to go straight into Extrude Boss and Base. So it'll pull that sketch right in here. Here you can see the default direction is incorrect, so I'll flip it right here to the left. And here I need it to go all the way up till it intersects this next surface. Well, instead of blind, instead of through all, there is an up to next option, which would be perfect for this situation. That up to next then ties it together so that no matter what this distance is, it's always going to keep pulling the extrusion until I hit the next surface. So that's looking good. This is again my seed feature, and now it's going to be the same idea as last time to create the cuts for the spokes. We'll go right into circular pattern. The feature, this time we'll select it from the graphics window. Notice I can click the feature itself, Boss Extrude 1 there. Is the correct feature name. I can come up to the pattern axis. Again, we'll use the same axis here. You can see it kept the 6 from our previous one. Here, instead of 6, we've got a lot more. It is the 50. You can see the nice preview there, and accepting it allows us to create that tooth pattern. And so notice the circular pattern here is saving us a lot of time because we don't have to draw each one of these individually. Obviously that would be a nightmare there. You would spend a lot of time. It'd be a very tedious process. And so here we're just making the single seed feature and having SolidWorks pattern it and create the overall effect for us. So last but not least, we have the threaded hole here. The 3/8 16 UNC, and it is right in line with a plane. It looks like it'll be in line with the front plane there. It's the center axis of the hole. So it is a tapped hole, so it's not just something you can use with the cut extrude. So we'll use the hole wizard here. And so here's the hole wizard. It is a straight tap, ANSI inch and bottoming tapped is fine. As far as size, we want it to be 3/8 16, and I believe up to next should work for both of these because we're going to basically have it start at this top surface and then go down until we intercept the bottom, or the inner cylindrical face, if you will, of the hole. So we've got the type set up for us. Now let's go to position. So the position is going to be on a cylindrical face, so I got the cursor here by selecting that outer cylindrical face, and then I'm just going to make a point here to define the center point of the hole. And at this point it is underdefined. It's just kind of floating in space, and we're in kind of a 3D sketching environment at this point since it is on that cylindrical face. So one thing I'm going to tell it is that that point in the front plane must work together, and so this point needs to actually be on the front plane, and so allowing us to have that geometric relation fixes that portion of it. That on plane relation is something that's usually found only in 3D sketching environments instead of 2D sketching environments like we have been in this part. You can also see if you look down at the very bottom right, it says editing 3D sketch here instead of the usual editing 2D sketch. It's just another slight variation of the SolidWorks environment there, depending on if you're in a 2D or 3D sketch. Here we basically have it centered, and by centered I mean it's right along this axis here. But what about this dimension here? And so that dimension needs to be 5/8 of an inch from that front face. And so one thing I can do is start a dimension. Here I'm going to select the face itself and the point. That allows me to put a dimension that's running right along the x-axis. And here, as usual, we put in our desired value. So 0.625 there. Here I'll go ahead and select it and go to 3 decimal places so we can see the full 625. So that looks good, and then I'll go ahead and accept it. Here I don't have it showing the threads, but you can see in the tool, or in the tree, excuse me, that it is a 3/8/16 tab tool. So just going to quickly put it to ISO. You can look here at our original isometric view and compare it to this one. They do look identical as far as I can tell. And so let's go ahead and pull some mass properties here. So the mass properties, 4.059 is the mass, which is good. And then negative 1.659, negative 0.002, and 0 for the x, y, and z coordinates of the center of mass. So it looks like we are in good shape. And so, as always, thanks for watching the video, and hope this has helped you with learning SolidWorks.